Okay, now, let's say we want to integrate over a circle of radius 4, centered at the origin. Again, you can think of a function above the xy plane of some shape and volumes and so forth. So what we have to do is we have to partition from, so here's the point 4, negative 4, 0. Here's the point. So pushing the x and it will negative 4, 4. There it is. Now, I'm not actually going to write out a partition. I'm not going to go through all the detail of writing out the general function, okay, the general form of the sum and so forth. But a shortcut this a little bit. And this is really what we always end up doing in practice. But we have to remember what's going on. We have to remember the partitioning and what the partitioning tells us and why that works. Okay, so we partition this x interval. Then for given xi star, we find the limits on y. Okay, well, so let's just say we have xi star here. Okay, well, that's going to be the case everywhere on this vertical line. If x equals xi star here, it'll be everywhere on the line. So what are the limits on y? Well, we know the equation for this circle. It's x squared plus y squared equals 16. So we just solve this, plugging in x equals xi star, and we get y equals square root of 16 minus xi star plus or minus the square root, meaning that you have a point up here and a point down here. So this would be xi star square root of 16 minus xi star squared. And down here, having not left myself room to write it, but it'll be xi star square root of 16 minus xi star negative square root of 16 minus xi star squared. Again, I don't have room to label that. Right before slide. Okay. That works just fine. Now, there's a geometric way we can do this. This is a circle. So we know the distance here. Likely we want to look at this triangle. Let's draw that triangle over here. And you know two legs of this triangle. What are the two legs of this triangle? If this is a line x equals xi star is just a number. Okay. Now you ought to stop and think about that, because this is a very important picture. And well, this side is xi star. This side is 4. Because this hypotenuse of this triangle goes from the origin up to the point on the circle This has radius 4, so this is a radius. It's like this point. Pythagorean theorem implies that the length is square root of 16 minus xi star. Square. Once I write that star, I feel like I've written the square. Be more focused. Okay, so there's the length of this side. So we know the length of this side is this. Okay, well, we have the same picture down here. So now, drawing just this much of a picture, you know that here, y is the square root of 16 minus xi star squared. And up here, y equals 16. Square root of 16 minus xi star squared. So what are the limits on y? Y goes from here to here, from negative square root of 16 minus x I star squared. It goes up to 16 minus square root of 16 minus xi star squared. So if we want to find the area, and I'm going to kind of show you this quickly because of time. The x goes from negative 4 to 4. And the area of the y strip, if you have a strip from here to here of width delta x of I, then the strip going to have y coordinates that go from negative the square root of 16 minus your x of I squared. And I'm not using x of I squared now because I'm writing a expression that applies to any coordinate x. Okay, so go from here to here. And that's with respect to y. And so whatever, and you can think of this now, okay? You have like a delta y here. So now you have this arbitrary strip. On this area. Writing expression for the volume. 16 minus xi star squared. Square root of that. Okay, well, from here to here, it's this minus this, which is 2 times this, times delta x. Okay. Well, in any case, you get this. And then, okay. Like here's your delta y, here's your delta x. You can think through how this corresponds to the whole process that we did previously. The area under the curve g of x, or volume, would be going to go with the same limits. But of course, you multiply the area, delta y by delta x, for a typical small rectangle in this strip, by the value of the function g of x, y. It would give you your total volume. I want to talk at least briefly about polar coordinates.